UDP stands for User Datagram Protocol. As we've discussed many times, UDP does pretty much nothing on top of the network layer basic service. So we could have segment lost, we could have segments arriving out of order. So no reliability, unreliable. Second characteristic of UDP is this: it's connectionless. Therefore, there's no handshaking, there's no connection setup phase, there's no connection setup delay. As soon as we have data to send, we just generate these UDP segments and push it out. Very low delay. While we have also very low reliability. Right. But hey, some applications would actually like low delay, and it probably doesn't care too much about reliability. Then these applications would be perfectly fine using UDP as a transport layer service. So some of the video streaming services, some of the gaming services that we talked about uses UDP. Skype's voice sometimes also uses UDP. DNS, getting the host to IP mapping, we need it as soon as possible. Therefore, UDP here. Now, if one of these DNS query or reply is lost, DNS server, the local DNS server is going to send another request real fast, so don't worry. And SNMP, okay, we have not yet talked about this protocol. It's called the Simple Network Management Protocol. Now, this protocol is talked about in the textbook, but it's in one of the later chapters. Most of the content there is to talk about building a database, defining the format, such that when we measure, for example, round-trip delay from one host to another host, we get to store these round-trip delay data. We get to store packet loss rate data. We get to store available bandwidth measurement data. All right, so SNMP there define these data structure for informations that measures the performance of the internet. SNMP also gets set up across all the machines around the world. If they are enabled, these machines will send these SNMP messages back to the SNMP database. And those messages are sent using UDP because, after all, these informations are nice to have, but they are not really necessary there to ensure the internet continues to operate. It tries to help such that the internet can perform a little bit better, but without these messages, the internet usually works just fine. All right, so those messages are also in UDP. Last point here. UDP does not do reliable transfer, but some applications might need reliable transfer services, but not 100% reliability is required. Then those might add the reliability at the level the application desires, okay, and does application-specific error recovery. Okay, so this is one of the reasons people use UDP. Not only because some applications doesn't care about having segment loss, some applications wishes the messages being really fast, and some applications want some level of reliability but not perfect reliability. There's some other use of UDP. Right? So some other advantages of UDP. There's no connection establishment, as we know, low delay. It's very simple. There's no handshake. It's easier to implement. There's also a small header. So this is a UDP segment. Once again, there's a header part. There's also a data part. The header part, very small. Just two 30 bits, 64 bits altogether, and that is 8 bytes. Very small header. There's no congestion control, so you can actually blast into the internet as fast as possible. All right. So these are a few other advantages of people using UDP. Okay. So there are 4 fields in the header: the source, and the destination port number, which we've already talked about. The two other fields we have not yet talked about is length. This is the size of the UDP segment entirely, including header and data. And the unit to count the length is byte. Last is the checksum. What's interesting about UDP is that, hey, if you send it out over UDP, there's no guaranteeing of reliable transfer, but you do get this. You get to check whether there's any bit errors in the data part of the UDP packet. And this is the way it works. It's called the UDP checksum. This is how it works. At the center side, we take the segment out. Okay, so take the entire segment, including the header, and lay the bits one row at a time, and each row 16 bits. So it looks a little bit more like this. Yeah, a row of 16 bits, another row of 16 bits. Okay, so you lay them out and then do what? Summing, okay, of these 16-bit rows. So add them up, and to be precise, it's called the ones complement sum, to be exact. Okay. And as a result, you get also a 16-bit output. That is called the UDP checksum. Right? So let's come back here in the example to explain how exactly it's done. So sum, binary add, 0 plus 1 writes 1 here, 1 plus 0 writes 1 here, 1 plus 1 writes 0 here and carry 1 over here. That's why, even though these two are zeros, we still get 1 down here. Okay, just do the binary addition all the way to the end. Now, there could be extra bits being introduced. No worry, what we do in the ones complement sum is to wrap this around and then add back to the number here. So that 1 being added here writes 0, carry 1 over, writes 0, carry 1 over, writes 1 here, and that's the end. All right. Now the last thing is just to do what? To the complement. All right. So complement is straightforward, flipping 0 to 1 and flipping 1 to 0. And so in the end, we ended up having the checksum, which is also 16 bits. And this is what's being placed in this part of the UDP segment. All right. So when that UDP segment arrives at the receiver side, receiver does the exact computation, take the segment out, and compute the checksum. That checksum after computation is compared to the checksum field in the packet header. Right? If there's no bit error at all, right, the two checksums should match, isn't it? So if this equals this, if yes, then there should not be error. But now be careful. There could be specific bit error patterns that the checksum might not detect. Okay, so maybe error, but chances very low. All right. But otherwise, if the checksum do not match, so there's clearly some error. Okay, so application layer there, finding a UDP segment having mismatching checksum can at least discard the packet, discard the segment, knowing that there's already something wrong.